It's really nice to be back here at LPS Digital. My name is Xavier Denis, and I'm the European Technical Marketing Manager at Nichia. Now I will present to you our latest research and development on our Light So Good solutions. I will speak today about technology on ipRGC sensitivity optimized LED spectrum and its application in color temperature tunable solutions.
So going on with the agenda, I will first introduce the base technology used in our latest development, why we have decided to proceed with our R&D, and how we developed our new LED. We will have a look at the phosphor technology used. Then we will move to the positioning of Nichia on melanopic ratio. On the third section, we will cover the results of our development, and this part will be split in two. So the first, it will be about the cyan LED for higher melanopic stimulation, and the second is the combination into a tunable solution to cover all CCTs with higher CRI and higher lumen per watt. Finally, we will look into further developments, especially with possibilities of tunable solution with our H6 technology. And then we will go on with the lesson learned and the conclusion. So our development actually started several years ago when we first had the vitasolis technology. In human-centric lighting application, there are two important technical characteristics that are often considered. The ipRGC stimulation is one of the key characteristics. Human ipRGCs are stimulated in the morning when the sun is bright and the sky is blue. So morning daylight has a higher content of lower wavelengths in the cyan region, which stimulate the cells. And to go on and to go one step further, we had to look into the second key characteristics, tunability, and in our case, color temperature tunability. So looking again at the daylight, it has a high CCT, generally in the range of 5,500 Kelvin to 5,800 Kelvin. And during the afternoon, the color temperature of daylight slowly changes until it reaches around 2,700 Kelvin at sunset, when it becomes a warm yellow. So our approach was to first create a cyan LED based on our SAE phosphor technology, and that will stimulate the ipRGCs. Combining it with a CR80 2700 Kelvin LED, we have the two characteristics into one lighting solution. And because both characteristics are correlated to one another, as they both arise from the exposure of human being to daylight. So as human-centric light solution tries to mimic daylight, the request for a tunable ipRGC stimulated solution is only a logical conclusion. Looking at the market trends on LED, we also need to see that there are 4 different steps that brings value to luminaire makers. Energy saving is always in focus for LED makers, as we always improve the performance of the upcoming LEDs, either with better luminous flux or better luminous efficacy. The second step is simple design. Tunability requires LEDs to be compatible in terms of footprint, size, and that gives simplicity to mount. quality of light is going on the top with high CRI and natural light. Finally, human-centric lighting has the most added value. So lighting for well-being and circadian effect. For human performance improvement is important for luminaire manufacturer as a market differentiator. After looking at market trends, we next needed to refer to some existing research like Lucas in 2014. Here we mainly focus on the optical properties of the human eyes. So the left figure shows the spectral curves of the absorbance of human retinal photoreceptors. The peak wavelength of spectral sensitivity of ipRGC is located around 480 nanometer. And we know that the ipRGC is related to controlling circadian rhythm. The right figure shows the transition of the total transmittance of human eyes with advancing age. The transmittance of crystalline lens between 400 to 500 nanometer decreases and changes into yellowish color with advancing age. This means that the emphasizing cyan component provides clearer view for middle-aged adults. Therefore, for those two researchers, we have information that the emphasizing cyan component is most important for an ipRGC LED spectrum. As mentioned before, we based our research and development on the vitasolis technology. So, as a reminder, let's look at what are the different features of vitasolis. The purpose of that LED was to improve a white spectrum and to focus on optimizing the spectrum from three features. The first one was to add a cyan component into the spectrum, so more cyan. The second was to decrease the yellow part of the spectrum. And the third was to widen the full spectrum. To do that, we also improved the red part of the vitasolis LED. The benefits by having more cyan was to increase vitality and decrease tiredness of human beings. By that, we also improve motivation and productivity. Reducing the yellow component of the spectrum helps us to have higher lumen per watt, something very similar to a CRI 80 LED, and also achieve a very good and crisper white. By widening the spectrum, we get a comfortable illumination, so a very good quality of light, good for the eyes, and we achieve a final spectrum which is close to a natural daylight spectrum. So this LED was really focused on human-centric lighting with no UV, in high power LED, and the different whites were available from 2700 Kelvin to 6500 Kelvin. The improvement of the cyan part of vitasolis was based on SAE phosphor. So SAE is actually the europium activated strontium aluminate phosphor, and that is responsible for the emission in the cyan region. We can see on the left part the crystal structure of this phosphor, and that is actually a special chemical treatment process that enhances the robustness of this phosphor, and this technology is really unique to Nichia. Looking into the center here of the graph, we see that there is enough absorption in the blue region, and that the emission peak of this phosphor is around 495 nanometer. So in order to broaden the cyan to green spectrum, the SA phosphor was very important to be introduced in our latest technology. Regarding Nichia positioning on circadian lighting, we believe that specifying melanopic lux of a source is not entirely correct. What should be specified is the melanopic illuminance of a source in melanopic lux. Same thing on the market, we see comparison of LED performances with the melanopic ratio. Actually, melanopic ratio was only ever meant to be a tool to calculate the melanopic performance of light sources with limited known information. The demonstration is made in the well building standard, as the requirements do not ask for a minimum value of melanopic ratio, but for a minimum level of equivalent melanopic illuminance. Additionally, there is requirements for visual lighting. And we believe that it's really necessary, as the well standard is stating, that there must be a balance between circadian lighting and visual lighting. For melanopic light, there are benefits, like the suppression of the production of the hormone melatonin. We have also benefit with the exposure in the morning and early afternoon in order to keep us awake. And obviously, the light is also regulating our sleep-wake cycle. There is also disadvantages with a very important one. It's definitely not to always be exposed to a high melanopic illuminance, else it will disturb our sleeping cycle. There are LEDs already on the market which are bringing melanopic light, but at the moment none of them are offering possibilities to reduce the amount of melanopic lights for the use in the evening, other than by lowering the total amount of light. So in terms of performance, it's definitely not ideal. There is also some tunable solution available on the market. The disadvantage is that the melanopic enhanced LED still emit light outside the melanopic sensitive wavelength range. So the melanopic light output of the solution cannot be independently controlled by just the melanopic enhanced LED. From the next slides and the next section, we will see the advantage that our research and development are bringing to counterbalance those negative aspects of the current solution on the market. The first result of our development is the Nichia cyan LED, a source with an ipRGC sensitivity optimized spectrum, fulfilling exactly the requirement of high melanopic output without emission in the rest of the spectrum. When excited with a standard InGaN blue chip, this phosphor produces an almost pure cyan emission spectrum. It should be clear that the new cyan LED by itself does not generate white light. So looking in the graph on the right, we can see that the spectrum is mainly having its wavelength peaks from 450 to 550 nanometer. The advantage of having neglectable emission at wavelengths longer than 600 nanometer is very high melanopic ratio value at 2.8. Going into tunability, the activation mode is achieved with the cyan LED, and the relaxation mode is done with a CRI 80 2700 Kelvin LED. An ipRGC, color temperature tunable, can be assumed to have two functions when it comes to circadian lighting design. First one is high melanopic light output, especially in the morning, and low melanopic output when it's not needed or in the evening. By separating this dual functionality in two LEDs, then it's also possible to design an actual circadian tunable light source. So the tunable light source is called Nichiatun. So let's have a look at the Nichiatun performance. When mixing the cyan light with the warmer CCT light of the 2700 Kelvin LED, the combined light can achieve color points between 2700 Kelvin and 6500 Kelvin. There is two main advantages of mixing those LEDs. The first one is that the high melanopic ratio at cooler CCTs. The second one is the opposite, the lower melanopic ratio at warmer CCTs. We can compare the Nichiatun and the equivalent standard illuminant with the same CCT for the full tunable CCT range. Those are the graph that you have on the right and the table in the bottom right. So beside having decreased the melanopic light at the warmer CCTs, Nichiatun has a melanopic ratio higher than the daylight at the cooler CCTs. This is seen in the first line of this table, where we see for the 2700 Kelvin that the efficacy ratio of the standard illuminant is less than the melanopic ratio of the Nichiatun. So Nichiatun is truly a circadian and untunable color temperature solution. In the current market environment, energy saving is still considered one of the primary targets of lighting products. So when comparing the efficacy of the melanopic light, Nichiatuns outperform existing tunable solution. And that is true when looking in the left graph. And we see that the higher the CCTs are, the higher are the melanopic efficacies. At higher CCT, the percentual difference in melanopic efficacy is largest, indicating the superior melanopic performance of the Nichiatun. On the right side, the luminous efficacy is still at the high end of most regulation and can certainly be considered an energy-saving solution, while still we are maintaining high efficacy. We can now move on to the fourth section about future development. For melanopic optimized color temperature tunable products, the ideal light is for warmer CCT, a high CI, and for cooler CCTs, a high melanopic performance. For the full CCT range, the light source must have a high luminance efficacy. That is a given just because of the performance of the LEDs in the market. Nichia Cyan already enables the high efficacy and the high melanopic performance. A next possible step will be to have tunability with the Nichia H6 high CI LED to maintain a high efficacy even at warmer CCTs. Nichia H6 LED has a unique red narrowband phosphor technology which enable a high CI without sacrificing the luminous efficacy. And this gives us three major advantages. First one on lumen per watt with an increase of 15 to 20%, which bring us to a level of efficacy comparable to CI 80 LEDs. Second is achieving a typical luminous efficacy of 200 lumen per watt. The last one is to have a minimum of a CI 90 with a R9 value of at least 50. Future development and optimization of the Nichia cyan and the H6 LEDs are still needed to enable a truly high CI and melanopic lighting product. We can already see the advantages of the H6 spectrum. So having a look here at the bottom graph, we see the distinct emission in the red part of the spectrum for a 2700 Kelvin version of the H6 series. Applications could be for luxury stores, restaurants, school, hospital, anywhere where communications take place. What is expected in the near future is that those optimized versions of the cyan and the H6 LED will be ready, which will be ideal matched for the melanopic high color temperature tunable lighting solution. In conclusion, the color temperature tunable lighting products are becoming part of the lighting manufacturer's portfolio. To enable this, we need to have smart lighting, and those solutions need to become more intelligent and independent. The Nichia cyan already enables high efficacy and high melanopic performance. Optimized ipRGC's stimulated LED in the cyan cannot work alone. They need to be combined with a white light. Nichiatun is consisting of the new Nichia cyan LED combined with a standard CI 80 2700 Kelvin LEDs to increase the circadian performance through the full color temperature tunability solution. For some application, higher CI will be needed. In this case, the H6 solution might be the right technology to be fitting in. So development are still ongoing to improve the performance of light sources that are part of the human-centric lighting.
So thank you very much for your attention. Please do not hesitate to contact me or my colleague at Nichia. We will be very glad to answer to your questions and give you more information about our ipRGC color temperature tunable solution. Stay safe and see you in person very soon.